This is a video on inflection points and concavity. The question states, find the points of inflection and discuss a concavity of f of x is equal to x to the fourth minus 4x cubed plus 3x plus 9. So inflection points and concavity are all about the second derivative of f. Remember, if the second derivative is negative, it's concave down. If the second derivative is positive, it's concave up. And when there's a change from concave down to up or up to down, then that point is a point of inflection. So let's find the second derivative. First, we find the first derivative, and that's 4x cubed minus 12x squared plus 3. And the derivative of the first derivative is the second derivative. So the second derivative is f double prime of x is equal to 12x squared minus 24x. To find the inflection points, we set that equal to 0 and solve. So I factored out a 12x and got 12x times x minus 2 equals 0. And solving for that, I get x equals 0 and x equals 2. So those are our x values for our points of inflection. To find our y values, we plug in x equals 0, and if I plug in 0, I get 9, and I plug in x equals 2, 2 to the fourth is 16, 2 cubed is 8 times 4 is 32, 16 minus 32 is negative 16, plus 6 is negative 10, plus 9 is negative 1. So I get my 2 points of inflection, 0, 9, and 2, negative 1. Now let's check for concavity. So checking for concavity is very similar to checking for increasing and decreasing intervals, except we use a second derivative. So I set up a table, and I'm going to have my interval from negative infinity to the first inflection point, 0, from 0 to the second inflection point, 2, and from 2 to infinity. And I'm going to put in test values. I'm going to say that negative 1 is between negative infinity and 0, 1 is between 0 and 2, and 3 is between 2 and infinity. So I'm interested in the sign of f double prime of x. So if I plug in negative 1 into 12x times x minus 2, I get 12 times negative 1 times negative 3 is a positive number. If I plug in 1, 12 times 1 times negative 1 is a negative number. And if I plug in 3, 12 times 3 times 1 is a positive number. So now I'm ready to make my conclusion about concavity. We can say that since the sign of f double prime of x is positive in this first interval, the function is concave up between negative infinity and 0. Since the sign of f double prime is negative in the second interval, we can say that the function is concave down between 0 and 2. And since the sign of f double prime is positive in the third interval, f of x is concave up between 2 and infinity. Notice that at 0, we go from concave up to concave down. So there's a change in concavity. So this is indeed an inflection point. And at 2, we go from concave down to concave up. There's a change in concavity. So 2, negative 1 is also an inflection point. And I'm done with the problem.